Hello, I'm
Hello.
back.
Yeah, you're back.
How are you doing?
I'm good. How was Japan?
Japan was great. Yes, I got a new T-shirt. You know.
Oh.
Broccoli. See, broccoli.
Ah.
That's
okay.
very advanced.
I see. Yeah, I saw it. I was just like, there's a woman
Yes.
on his shirt with a name,
It's
and I was
not
like,
a
oh.
woman. It's a broccoli.
It kind of
dude.
looks like, okay, well,
It's a kung fu, dude.
it could be, I guess, anything.
Yes.
Gender
Japan
neutral.
is great. Yes.
Excellent. Yeah. How long were you there for?
A couple of weeks.
Couple of
So it
weeks.
was very nice.
Cool.
Yes.
Very nice.
Nice break.
Well deserved, I hope.
Yeah. We'll
So,
see.
yeah.
So last episode was great.
Yeah.
I really liked. I saw wrong, and yes, was really nice.
Yeah.
I wasn't there, but
Yeah, graphics
Lots of
always cool
views,
to
yes.
just learn more things about that area, and it was also really nice to see the developers and the QAs behind the features.
Right.
Yeah, it's really
All
nice
the
to
team,
see
yes.
who works on that. I feel like we don't do that very much anymore. So.
nice.
Yeah.
Let's do it more. What do you have this time?
So, well, we've got the debugger episode lined
Nice.
up for you folks. Talk to Steve and Greg about, and as Steve will tell you in the interview, Greg is the foremost world expert on VS debuggers. So, I know you guys are going to learn a lot of useful things in this episode. So, hope you guys will enjoy it and tell all your friends about how they can be more productive with the VS debugger.
Yes,
and
it's a great debugger.
Yeah. So let's get
Let's
right
go
to
watch it. Yes.
Hi everyone, welcome to our latest episode of Channel 9's GoingNative. My name is Gabriel Ha, behind the camera, and I'm here with Greg and Steve. Why don't you guys tell us a little bit about yourselves and your history at Microsoft?
You go, Greg, you're old.
Okay, my name is Greg Kelly. I've been a dev on the debugger for a very long time now, for 14 years. Yeah, I'm going to talk about native debuggers today.
And my name's Steve Carroll. I've been with Microsoft for about 11 years, and for all that time I've been working in one way or another on what we call diagnostics. So the story I usually tell people about this is like, if you ask a developer, what is it that you do for a living? What do you do all day? If you try to explain it to your grandma, most developers will say that they write code. And I will posit that that is a lie. That is not what developers do all day. What developers do all day is they write code for 5 minutes in the morning, and they spend the rest of the day fixing it because it doesn't work. And so diagnostics, our job was to make it so that it would work. And so it was like making the biggest possible difference you could for software development for devs. And we are, and so I've been the dev manager for diagnostics for about 3 years, up until 2 weeks ago when I became the dev manager for Visual C++.
All right, well, very cool. So Steve, why don't you tell us a bit about what we're going to be talking about today with the debugger?
Sure. So we thought that the most impactful things we could do with your time would be to, first of all, give you just a little bit about how debuggers work. When you understand that model, it can help you be more effective and understand what's really going on when you're pushing F10, F9, and F11 in the debugger. And Greg is the world's foremost expert on that. So, and then afterwards, we're going to take a look at tips and tricks. It turns out that the debugger, because it's been around for how many years?
I don't know, a long time.
Ours, a lot more than him, more than 14. Is that there are many, many pieces of the debugger that we're very confident are useful, but that no one knows about. Things that we have carefully hidden on right-click menus and otherwise kept away from you. And today we're going to take off the curtains and show you where all the cool stuff that's hidden that's going to make you more effective.
Fantastic. Let's get right to it.
So what we're going to do is we're going to walk you through what happens in the debugger when a developer sets a breakpoint and then hits F5 to make it go. All right, Greg, so what's the first thing that happens in the debugger after you've set a breakpoint and hit the F5 button?
So I always like to draw diagrams. I find people can understand things better that way. So we've got two processes that matter. So first we've got Visual Studio over here. And it's got a bunch of stuff in it. But for our purposes, we're just going to talk about the debugger down here. So the debugger is going to be communicating with some target process.
So that's the thing that you actually are debugging?
Yep.
Okay.
So it's useful to think about the address space of it. So we've got foo.exe over here, which is mapped at, say, 10,000 hex to 20,000 hex, or whatever it happens to be. So you've got some source file over here, foo.cpp, and the user presses F9 on line 12. So we've got line 12. So the first thing we need to do is that before we have done all this, we would have needed to load the symbols for foo.exe. So the way that works is that As the target process was starting, at some point, the operating system decided to map foo.exe into this address space. And at which point, the debugger would have gotten a notification that that happened. And this is before any code can run in foo.exe. And we will temporarily pause that process while we go off and we use various things to try and load the symbols.
When you say the symbols, what do you mean?
There's a PDB file.
Which gets produced by?
The compiler and linker. So really the linker.
And so like, what are the kinds of things that are in a PDB?
For the purposes of our little demo, the most important thing is that it has the tables that allow you to map from lines of a particular source file to the address ranges where that line maps to. But they have other things too, like, for example, to support expression evaluation, it has all the types that were used in your program. And it has all the local variables and global variables and static variables.
So it's basically a set of lookup tables that you can use to figure out where the compiler put things so that you can map the dynamic view to what's back in the source file.
Yep. So first we'll look up foo.cpp in the PDB, and we'll find an object that represents that, and then we'll query to see what source lines, they're called, are around line 12. And so we'll find one, and that will tell us that foo.exe RVA1234 or whatever is where that source line is. And so at that point, all we have to do is we have to update the instruction stream of that function where foo.cpp line 12 was, so that instead of having the real original breakpoint, the real original instructions that would be executed, it now has a breakpoint instruction there.
What's a breakpoint instruction?
It is a special instruction, and one of the characteristics of it is that it has to be of size equal to or less than the smallest instruction. So on x86, it's a 1-byte instruction. It's 0xcc. So we'll take whatever instruction was there before, and we'll replace the first byte of it with 0xcc. And then that causes that when that function runs, it will generate a hardware fault that goes to the kernel, and then the kernel will tell the debugger that this breakpoint instruction was hit.
So in a lot of ways, debugging is an orchestration exercise between the operating system, your process, and the debugger.
Yep. Some of the other interesting events we might get from the kernel are when threads are created or when new modules load, as we sort of talked about with breakpoints, but it's a little bit more general. Anytime an exception happens, so a breakpoint is an exception, but there's other types too, like if a user threw an exception object, or when modules are unloaded or threads exit as well.
So now I've managed to hit that breakpoint. You replace the instruction with CC so that when the processor hits the XCC, it triggers, it warns you, which makes you break at that line in the source code.
Yep.
Okay, so now let's imagine I actually want to step. So I hit F10. What happens next?
So the first thing we have to do is we have to put back those original instruction bytes, because otherwise the processor will just continuously fault on that breakpoint. You can think of it in the simple way of we just put back the original instructions, we set the other threads so that they're not going to run by suspending them, and then we have done something to cause it to stop on the next instruction. Kind of the most common thing is that on x86 CPUs they have something called the trap flag. So we update there's a set of registers for that thread so that the processor will stop again after it's executed one instruction. And so after we've changed the registers, then we continue the process. The kernel will eventually get around to scheduling that thread to run again. It will execute one instruction, and then the CPU will cause another exception to occur for this trap flag. And then if that didn't get you to the next source line, we can then repeat the exercise again and again until we actually get there.
It's a big loop, basically.
Yep.
So now I've hit a breakpoint, then I've stepped so that I'm controlling the execution. I guess the other most common thing that you would do with the debugger is now inspect a variable. So let's imagine I open up our old friend the watch window and I type x to see a local variable. How do you guys figure out what the value of x is in the program at the point where you've broken?
So going back to that PDB file, so as we've talked about, the PDB has some information about all the variables in your program. So let's assume x is a local variable, because that's probably the most common case. So the PDB so first of all, it has like a hierarchy of scopes. for that local function. So the debugger first has to walk those scopes and figure out, okay, is there a local variable called x? And in this case, let's assume that there was one. So then the PDB will also tell us how we can find x at whatever instruction we're at. So it might say something like that it's at EBP minus 5, or 5 is probably a bad example, but
because the compilers decided where to
Yes.
store that variable in registers or in the heap or relative to the stack.
Yep. So then we will go and read the thread context to see, okay, what's the value of EBP, and then we can just do the simple subtraction. And then we can read the value of that variable from the target process.
Do you have to format that in some way? How do you decide how to show it?
It kind of depends on what type it is. So suppose if it was an int, it's pretty straightforward. We're just calling like sprintf or something like that. If it was a pointer to some class, then it could be fairly complex to format it. We have all these different rules.
Like an STL list or something.
Yes. Yeah. So there you're talking about once you've got that pointer to the STL list, then you've got to read a bunch of member variables of that STL list, which again we can get from the PDB because we can get the type information. And then on top of that, we have sets of rules you can apply to those. So we have this thing called Natvis that we'll talk about a little bit more later in our tips and tricks that can make it so that instead of just seeing a bunch of member variables, you see something that is human understandable.
And that's one of the debugger features that really separates the experts who are super effective from people who are sort of new. And so yeah, glad we're going to look into that in a second. So at this point, Greg's going to show you some tips and tricks for the debugger that you can hopefully walk out of here and go make use of in your day-to-day work. So the first thing I think we're going to look at is what we call XC projects.
XC projects are useful if you are in a world where you have some source code that you've built in some way, say on the command line, but you don't, or maybe somebody gave you an XC and you don't actually have source for it.
CMake.
Yep, CMake is a good example. So what I want to do is I want to be able to somehow debug an XC without having a project for it. And so we actually have the ability to do that, but it's super hard to figure out how to do it. So
I think 0 people figured this out.
Yes. So you can go to Open Project, and instead of pointing at a normal project file, you instead just point to an XC. So in this case, I've got one that was actually built through Visual Studio, but it didn't have to be. Here I get this project, there's no source file for it, but now there's debug settings. So for example, I can change the arguments for it if I wanted, or I could, I don't have to do anything, I could just start debugging. So I can press F10, and now I'm debugging this.
If you want to practice this at home, you can try it with notepad.exe.
Yep. And in fact, this is true for C++ projects too, but there's also some interesting options if you've got an XC that you can't even start normally. So you can change this attached to be true. And now if I had native demo app running, it would just attach to it when I hit F5, a lot faster than having to each time go back to the attached to process dialog.
So that would be really useful for things like services.
Yep, or a child process of an app. The next tip and trick we have for you is one that I'm not going to bother demoing. It doesn't make a great demo, but it is a great feature, and that is that if you've ever tried debugging release code and found that the debugger lies to you about every local variable and that it's just a terrible experience.
Not because we hate you.
While it's not a great experience with this, it's a whole lot better, and that is that there's an undocumented compiler flag called /d2zi+. And so if you throw that in, then suddenly your PDBs will get bigger, and that's because they actually have some useful information in them.
So what are the kinds of things that will suddenly be correct after you apply this into your release compiler settings?
The main thing is that suddenly local variable information is now much more valid. In addition to that, there's also inline information, which the Visual Studio Debugger doesn't currently take advantage of, but likely will in a future release.
Next up, I think we're going to look at trace points, which I think is definitely my personal selection for most useful, not used feature in the debugger. One that any developer could use today and get some benefit from if they had only found the right-click menu that we hid it under.
So we've got a silly little demo app that I have. And so here I'm calling something in a loop, and perhaps for timing reasons or whatever, I don't want to actually have to stop and inspect every time, but I can instead right-click on that breakpoint and change the when hit settings. And then I can tell it to print a message. So for example, I might evaluate the variable x, and I want to see what I'm sticking in that array, which in this case is x times 2. So now I can cause it to print a message every time it hits that code instead of actually stopping.
One thing probably worth pointing out is that dialog actually has the information about how to use the feature in it too. So if you're wondering how to like format these arcane invocations, it's all in there.
So now let's run our little program. And if we go to the output window, we can now see all of the output from our trace point.
I find one of the most useful things for this particular feature is sometimes Excel is the right tool for debugging. And so this is a really easy way to do your own kind of CSV, just output into the output window, copy it into some text file, rename it .csv, import it, and then do whatever the thing that you need to do across the gigantic array is. I think from that we're going to transition into talking about expression evaluation. We touched on this a little bit when we were talking about how debuggers work, and I think Greg has a couple of different ways that we can show you how to do a better job with expression evaluation.
For my first tip in this area, let's step into this function that I've implemented in another DLL. So here's a function that I've implemented in another DLL, and for my demo cases it's a really simple function, or silly. But you can see this pattern in some cases where you've got some pointer here. In this case, I called it pcontext, which has some useful typing information that the DLL I'm currently in doesn't understand. But if I could somehow get the debugger to evaluate in the context of another DLL, then I could get a much better display. So it turns out that this is actually possible to do. So here I've got this comment here to show you how to do it. You name the name of the exe or DLL and then bang, and then whatever type. And so now I've told it to look at this pcontext variable as if it's casting it to the CMyContext object. And so now you can see that instead of just a pointer, I can now see the same representation I would see of it in the original DLL.
And this is, I guess, a bonus tip or trick which Greg is showing you, which is it turns out if you put debugger watch window type things in the comments of your code, you can actually use that if you do the hovering debugger thing. What do we call those?
Data tips.
Data tips, thank you. If you do that, with the data tips will actually format it appropriately. But of course, you could have also copied that into the watch window and it would have had the same effect.
For my next tip, let's go over to this code. The debugger has a number of what we call pseudo-variables, which are essentially some interesting state that the debugger can tell you, but you may not have a variable for it. So for example, in Win32 programming, a really useful thing is to know what the last error that was set was. You've got some function that's failing in Win32 that you didn't actually expect to fail, so you didn't call getLastError yourself. You can, under the debugger, call getLastError. And that is called @error. Again, showing that. We can now see that error value is 5. Well, it turns out that,
5?
well, that's useful. It would be really nice to see that value as, a Win32 error. So there's also, we have these things called format specifiers, which we'll talk about a little bit more in a second. But one of the useful ones is "HR," which says formatted as an H result or a Win32 error. And so if I hover over that, I see that this is in fact error access denied, which you could kind of guess in this case, but in other cases it might not be so easy.
The ones you haven't memorized yet, it's really good for.
Some other interesting pseudo variables are we've got $env, which you can see the environment block. Another thing that's useful is you can right-click on this little text visualizer and then you can see the whole thing printed, which is a little bit more useful of a display than just as one large string. You can do $command line. Will tell you the command line for your exe, which in my particular case isn't super useful, but you can certainly imagine cases where...
Certainly it's passing arguments.
Yep. Those are probably the most useful pseudo variables. For my next tip and trick, I wanted to talk about some more format specifiers. So there's an msdn page where we list a whole lot of them, but some of the most useful ones I use are, you can use comma and some number on a pointer, and that will treat it as an array of that size. So for example, if you look at my pint array, I allocated it up here so the compiler doesn't know how many elements are in it, and therefore the debugger doesn't. But if you tell it that you want to see it as a 20-element array, you will then see the view of the 20-element array, whereas if I just look at it, all I get is the one element because it thinks it's a pointer. So a lot more useful. That's probably the most useful one. Some other examples are, if we keep going in my little program, here I've got a UTF-8 string here, and if you look at just the regular display of it, it's just going to format it as ASCII, which is not going to produce terribly useful results unless it happens to be all English characters. So if we look at it with the "S8" format specifier, we'll tell the debugger that it's a UTF-8 string, and then I'll get something more useful. Which, if one of the translate websites that I used was right, this should say "Hello World."
Hello World. Nailed it. It's one of my jobs, and it's reading Japanese error strings for the team.
So at any rate, as I said, if you follow this link, you'll get a whole bunch of more format specifiers that we've documented. The last thing I wanted to demo within this program was, you saw earlier that if you look at a string, you can sometimes get this little magnifying glass. Well, it turns out we can do more than just format it as text. We also have a bunch of other visualizers. So one of the ones that we have that we added for update 2, if I recall correctly.
Of VS 2013 update 2.
Yes.
Yeah.
So here, if I had this lovely blob of JSON text that's just pretty hard to understand by hand, I can dig through it and get a nice tree and search through it and things like that.
You can use it with the Project Casablanca.
Yep. One other tip and trick I wanted to talk about was Natvis, which we talked about earlier. So if I look at my vector here, I get to actually see the 20 elements and the size and stuff like that. And you might wonder, well, how did we do that?
How did I get here?
If you don't have that, for example, this is what you would see. This is, if you do comma bang, not terribly useful, but just to see the raw view of it, you could have seen this lovely view, and aren't you glad you don't have to watch this?
Now you are a sad STL developer.
Yes. So if you look at stl.natvis, you can see how we did it. So here's a bunch of rules. So that says, first, the display string element is this part. You know what, probably better if I brought up not the raw view. So this line here is called the display string. And then the other is what happens when you expand it. So as you can see, we're going to have an element when we expand it called bracket size and bracket. And so this describes how we calculated that, which is we subtract those 2 pointers. And then the capacity is this size, and so you can see how that was calculated. And then you can see all the array elements that will append with the bracket number syntax. And so here's how we know the size of it, and here's where we start the array. You can browse through our Natvis files if you want to kind of see how we formatted certain things. And you can also make your own Natvis files. If you dump in any file called with a .natvis extension into the My Documents, Visual Studio, whatever version, visualizers directory. We will parse those when we start debugging, and then we'll read your rules.
So you can document any kind of like really hairy DLL that you have. You can specify one of these so it can put it in a way that would make your whole team more productive. So you can make that win for the whole team if you happen to know how you want to format that data. Or if you think you can do a better job formatting than the defaults, go ahead and modify. It looks like next up we want to talk about the modules window.
All right, so let's bring up the modules window. So one window that perhaps not everybody notices is the modules window. So here we can see all the modules that are loaded into your process. And probably the most useful thing you can do with this is you can kind of understand why your breakpoints might not be binding. So for example, you can check, did I load symbols or not, using the symbol status icon. And if you find that symbols are indeed not loaded, then you can right-click on here and bring up symbol load information and see where all we looked. Well, in my case, we have it, so not very interesting, but here, maybe we should look at one. Let's see, do I have any that, I guess I don't have any that we're missing that aren't disabled. So at any rate, it would show you all the places we looked and why either there was no file there or that it didn't match.
And the order that we look at your symbol path and you know, when the symbol server is not on and those sorts of things.
Yep. Here, I've got a line that's going to call this little silly helper method, and I've got a method that I actually might want to step into. So if I was just hit step in, then it's going to take me to the silly little helper method.
Holder.value, basically.
Yes, holder.value. But I can right-click on this, and I can bring up the Step into Specific menu. And here I get to pick what I step into. So I can say to step into print, and then it will skip over the myValue method that I didn't want to step into. And that might sound like a silly feature, but sometimes in C++, you can find that you've got like 25 different silly methods that are all being called on the same line, and now you get to skip over all of them.
So before we wrap up, parallel windows.
I don't have a great app for demoing this, but I just wanted to call out the fact that if you're in heavily multi-threaded code, we have a bunch of windows that can present some interesting views for this. So they're all sort of grouped together here under Debug Windows. We've got the Tasks view, which will show you all your PPL tasks. We've got the Parallel Stacks window, which can, even if you're not using any sort of the task paradigms, you just got a bunch of threads, the Parallel Stacks window can show you the stacks of all your threads at once, which can be useful for data parallel apps. And we've got the Parallel Watch window, which allows you to evaluate a local variable across multiple contexts, which can be useful for either recursion code or if you've got data parallel code.
Hey, I just want to thank everybody for tuning in, and thanks for listening to us talk about the debugger today. Thank you.
Hey, that was great.
Yeah.
I really like the debugger is always something, you know, the technique behind it is really, really interesting. And there is so many things, and it's so useful also, come on.
Yeah.
You know, everybody needs to debug, you know, apart you that you write perfect code, but that's okay.
Exactly. Yeah. So, you know, I'm a program manager now, but
Right.
the times when I was a developer in my internships, like there are a lot of things I wish I knew about the debugger that I learned in this episode, especially the trace thing where you can pass over a for loop without having to F10 every single time and spit out the output.
And speed out the output. And you can speed out any output, not only on the for loop.
It's like so flexible.
That's very nice.
Yeah.
And there is, you know, more things coming, so it's very, very nice space.
Yeah.
And useful, man.
Definitely.
That's great, that's great. So this was really good.
Yeah, so as you guys might have caught when Steve was introducing himself in the episode, so Steve is the new Visual C++ dev manager, which means Ale is no longer
the dev manager for
the
Visual
dev
C++.
manager for the team.
Yes.
And I guess because of that, like just logistically, you're probably not going to be hosting.
Yeah, I
anymore.
moved to the Internet of Things team,
Yeah.
always in you know, in Microsoft, of course, in Windows. So still, you know, ready to develop developer experience, C++. So I think you're still gonna see me. Maybe I'm gonna be on the other side of the camera.
Yeah, probably on the other side of the camera.
Yes,
Yeah.
I really trust you to come and film me.
Well,
So,
I appreciate
well,
that.
this is kind of a goodbye for, you know, Channel 9 hosting.
Yeah.
But, you know, I really enjoyed this.
And
I'm sure you
I
can
have
do it.
really enjoyed working with Ale
Nice.
as a co-host. Like, you know, when I was sort of dragged in, but not really dragged into
Yes,
the
a
role.
little
Like,
bit,
I
right?
had no idea what was going to go on. I was like, you really want me to be a host for this
Yes,
thing?
it
And,
worked very, very well.
and this guy's been great. Just
Oh, it's
funny
okay. No.
and very knowledgeable. And I'm going to
It's
miss
okay.
you.
That's fine. We're not that far, so I'm sure you can have me a special guest another time.
Yes.
That's great.
You guys can look forward to that. So
Okay, thanks
thank
a
you,
lot.
and,
Thanks for everything, man.
It's been real.
Yes, that's really great.
Yeah.
So
Good luck with everything.
yeah, absolutely. Same to you, man.
Thank you.
Bye-bye.
Bye.